lab, we will continue with applying the machine learning method on the housing dataset from California. So first, in the step 1, we read the file from the we read the dataset from the file, and then in step 2, we explored the data analysis. We plotted one interactive box plot per each variable in the dataset using Plotly. Then we plotted a histogram of each of the variables to see the distributions. Then we found a way to visualize the relationship between the geospatial attributes, longitude and latitude, with the median house price using Folium. Then we identified all the missing values in the data, filled them using an imputer from sklearn, then double check if we still have those missing values. Then in step 3, we performed feature engineering. We created 3 new variables: average rooms per household, average bedrooms per room, average population per household. Then we performed the splitting of the data into training and test set using the library from sklearn. Then we performed a standard scalar and a robust scalar on both the train and the test feature data. Then in step 4, we developed regression models. We implemented linear regression model and random forest regressor model, and in this lab we will implement XGBRegressor model. We will try our best to find the best parameters for these models to make sure that they have the best accuracy using RandomizedSearchCV and GridSearchCV. We will evaluate these models using root mean squared error and mean absolute error as the criteria. And we plot a comparison between these 3 models. So in the model 1, we fitted and predicted linear regression and found the accuracies in terms of root mean square error and mean absolute error. Then in the second model for random forest regressor, we found the best parameters using randomized grid search and randomized search CV and grid search CV, and we found the root mean square error and mean absolute error of the predicted values. Then in this model 3, therefore we will fit XGBRegressor model and we will predict and we will find the root mean square error and mean absolute error. Let's create a parameter grid. Let pram_grid equal curly braces parameters used by XGBRegressor and underscore estimators are 100, 200, 300, 500, 800, 1000, 1500 and 2000. Max underscore depth is 3, 4, 5, 6, 8, 10, 15, 20. Gamma is 0.1, 0.2 and 0.3. Learning underscore rate is 0.05, 0.1, 0.15 and 0.2. We will print the from grid. There are 8 times 3 times 4 equals 768 models in total, from which models will be randomly picked and fitted to get the best score. So from sklearn.model_selection, we import randomized search CV. From XGBoost, import XGBRegressor. Then we create definition to find the optimal hyperparameters for XGBRegressor model. Def XGB underscore randomized search CV of the train feature data, the train target data, and the param grade. Define the classifier. Let XGB random CV equal randomized search CV open bracket XGB regressor of random underscore state equal 1, 2, 3, 4 comma param underscore distributions equal param grade comma CV equal 5 n underscore iter equal 2 and variables equal 2. Close the bracket. Then we fit the model onto the robust scalar feature values XGB random CV dot fit of the train feature values, feature dataset, and train target dataset. Get the complete details of the best model. Print best XGB regressor model is XGB random CV dot best underscore estimator underscore. Print best XGB regressor model is XGB random CV dot best underscore score underscore retain XGB random CV. Call the randomized search CV to find best XGB model. XGB random CV of standard scalar equal XGB randomized search CV. So we're calling the function to use the randomized search CV to search for best parameters for the best model. So the input is the standard scalar train feature data and the target train data in the param grade. Fitting 5 folds for each of the 2 candidates, totaling 10 fits. And we get the model, the best model of XGB regressor, and these are the parameters. Best XGB regressor model is a model score. The best score for the best XGB regressor model is 0.8236 and so on. Then we call the randomized search CV function to find the best XGB model on the robust scalar feature data. Let XGB random CV of robust scalar equal XGB randomized search CV of the robust scalar train feature data, comma the train target data, comma param grade. Fitting 5 folds for each of 2 candidates, totaling 10 fits. So the best XGB regressor model score is 0.8338, so on. Then we get the best hyperparameter values that we searched for. XGB random CV as standard scalar dot best underscore parameters underscore is n underscore estimators equal 1500, max underscore depth equal 10, learning underscore rate equal 0.15, gamma equal 0.2. Get the best hyperparameter values that we searched for. XGB random CV robust scalar dot best underscore params underscore gives n underscore estimators equal 200, max underscore depth equals 6, learning underscore rate equals 0.1, gamma equals 0.3. Next, we are going to perform GridSearchCV open and close bracket to see if we can improve the best score. We create a definition to find the param grade from the GridSearchCV. Def XGB underscore param underscore grade of input is XGB random CV. So this is the best standard scalar and robust scalar. We will input the best model from the randomized search CV. Assign variables to random search CV best parameters. let n equal XGBRegressor dot best underscore params underscore of n underscore estimators. Let LR equal XGBRegressor dot best underscore params underscore of learning underscore rate. Create a parameter grid. Let param underscore grid equal curly braces, parameters used by a random forest regressor. N underscore estimators is NA minus 200, NE minus 100, NE plus 100, NE plus 200. Number of trees in random forest. Max underscore depth, which is the maximum number of levels in tree, is XGBRegressor dot best underscore params underscore of max underscore depth. Gamma is XGBRegressor dot best underscore params underscore of gamma. Learning underscore rate is array of 0.01. Learning underscore rate ranges from 0.01 to 0.3. So let's choose some of the values. So 0.01 comma learning rate minus 0.05, learning rate plus 0.05, and learning rate plus 0.1. So the best model learning rate we found was 0.1 here for robust scalar data set. So the learning underscore rate will range from 0.01 to 0.2. Display param grade, retain param grade. Now let's call the function on the standard scalar and as well as the robust scalar. Call the function to find the param grade. Let param grade SS equal XGB underscore param underscore grade of XGB underscore RandomizedSearchCV underscore SS. And that gives n underscore estimators 1300, 1400, 1500, 1600, and 1700. Max underscore depth is 10. Gamma is 0.2. Learning underscore rate is 0.01, 0.0999, so on, comma 0.15, 0.2, and 0.25. The total number of iterations that GridSearchCV will do is 5 times 1 times 1 times 5 equal 25. Call the function to find the parameter grid. Let param grade RS equal XGB param grade. We calling the function XGB underscore param underscore grade of XGBRegressor of robust scalar. Let n underscore estimators values are 0, 100, 200, 300, 400. Max underscore depth values is 6. Gamma value is 0.3. Learning underscore rate values are 0.01, 0.05, 0.1, 0.15, so on, 0.2. The total number of iterations that GridSearchCV will do is 5 times 1 times 1 times 5 equal 25. Definition to find the best XGB model by GridSearchCV. So definition: find underscore XGB underscore GridSearchCV of train. The inputs are the train data set and the param grade. Define the classifier. Let XGBRegressor equal GridSearchCV of XGBRegressor open and close bracket, comma, param underscore grade equal param underscore grade, the input parameter grade, comma, cross validation equals 6, n underscore jobs equal -1, comma, webos equal 2. close the bracket. XGB underscore GridCV dot fit of X the train data set. Get the complete details of the best model. Print best XGB regressor model is XGBGridCV dot best underscore estimator underscore. Print score according to the metric we passed in refit. Print best XGB regressor model score is XGB GridCV dot best underscore score underscore return XGB GridCV. Call the function to find best XGB model by GridSearchCV. Let XGB GridCV SS standard scalar equal. Call the function find underscore XGB underscore GridSearchCV of a train data set. So for standard scalar feature data and the target train data and the parameter grid for standard scalar. Fitting 6 folds for each of the 25 candidates, totaling 150 feet. And the best score for the best XGB regressor model is 0.8309 and so on. Call the function to find best XGB model by GridSearchCV. Let XGB underscore GridCV underscore robust scalar equal find underscore XGB underscore GridSearchCV. So we are calling the function of the feature train data from robust scalar, comma the train target data, comma parameter grid from robust scalar. Fitting 6 folds for each of 25 candidates, totaling 150 feet. So the best score from the XGB regressor model is 0.8394 and so on. Evaluate the best XGB regressor model. Let model equal XGB GridCV SS dot best underscore estimator underscore. Let array of model RMSE MAE time taken equal run underscore model of model comma standard scalar train feature data, train target data, and standard scalar test feature data and the test target data. Store the final scores. All results standard scalar dot append of XGB regressor XGB GridCV SS dot best underscore score underscore RMSE MAE time underscore taken. Print all results SS. So we can see that linear regression, random forest regressor and XGB regressor. From out of this, the best score is from XGB regressor. The best score is the highest, and the root mean square error and the mean absolute error is the lowest, but the time taken is the highest. The performance matrix is the smallest. XGB regressor performed the best out of all 3 models tested, but the time taken to fit and predict is much higher. Then we evaluate the best XGB regressor model from the robust scalar dataset. Let model equal XGB GridCV RS dot best underscore estimator underscore. Let array of model RMSE MAE time taken equal run underscore model. So we calling the function run underscore model of model XRS robust scalar train feature data and then the target data. Then these are the train data and then the test data from robust scalar. Store the final scores. All results robust scalar dot append of XGB regressor, comma XGB GridCV RS dot best underscore score underscore and RMSE MAE time taken. Print all results RS. So we get from these three models here, linear regression, random forest regressor and XGBRegressor, the best score is highest for XGBRegressor, but the root mean square error and the mean absolute error is the lowest for random forest regressor model, and the time taken is the highest for random forest regressor model and lowest for linear regression. So the performance matrix for random forest regressor is the smallest. XGBRegressor performed better in terms of the time taken to fit and predict the model.